Good morning, everyone, and welcome to the Cable Labs Informed webinar series. Very pleased that you have chosen to be with us today. I'm Glenn Russell. I'm a member of the research and development team here at Cable Labs, and I'm going to be your host and moderator for today's program entitled Introducing Micronets, Bringing Network Segmentation and Machine Learning to Home and Small Business Networks. As the number of connected devices on home and small business networks explode, an easy-to-use platform to manage these devices and enhance security is imperative. Cable Labs Micronets is an innovative approach to network management. It's a system that provides enterprise-level security that's highly adaptive and effortless. Today, we'll provide you with valuable information on this technology platform, how it was created, how it is evolving, and the next steps in the development process. We'll also highlight the key benefits for consumers and provide you with details on how you can be a part of this broad industry effort. Note that we are making all of today's presentation slides and a replay of webinar available to you online. And we've already posted a PDF of today's slides for you in the handouts section of the GoToWebinar software toolbar. So if you go to your dashboard, you can download that PDF file right now. It's got a number of handy links in it that you might want to refer to. And as I mentioned, we're recording this, and next week we'll be able to post a live stream so you can access a full replay of today's webinar. And I'm pleased to introduce our expert lineup of speakers today. Mark Walker, Director of Technology Policy, Matt Tooley, Vice President of Broadband Technology at NCTA, and Darshak Thakur, Principal Architect and Security Technologies from Cable Labs. Mark's going to get us started by providing an introduction to Micronets and talking about some of the solutions and benefits that they can provide. Darshak's going to follow with an explanation of how the technology works. He's going to talk about the advantages of the Micronet architecture and the software tools that we have developed to help integrate Micronets into networks and consumer products. And Matt's going to conclude with a discussion of use cases and some of the benefits to the customers. And a reminder to all participants that how you engage with our speakers and ask them questions is you type them in using your GoToWebinar software toolbar. And we're going to take some breaks along the way, and we're going to field as many questions as we have time for. And we do value this interaction, so please take us up on the offer. So it's time to get started. I'm going to turn the floor over to our first speaker, Mark Walker, Director of Technology Policy at Cable Labs. Mark?
Thanks, Glenn. So glad to be here today discussing Micronets. The number of connected devices in our lives is exploding, whether at home or at work. Not too long ago, the only devices connected to the internet were desktop and laptop computers. Today, with the explosion of the Internet of Things, we see the number of connected devices increasing dramatically in home and small business networks. These include connected TVs, smart thermostats, security cameras, doorbells, door locks, lighting, voice assistants, and picture frames, to name just a few. As the number of connected devices increases, these home and small business networks begin to look and feel a lot like enterprise networks, requiring similar management and security controls. Cable Labs Micronets is a framework that brings network segmentation and other enterprise-level security controls to the home and small business customer in a transparent and easy-to-use manner. So what's driving this rapid increase in connected devices? IoT promises to improve our lives, increasing convenience, efficiency, and productivity. Many of the same applications seen in the home are also relevant to small businesses. For instance, physical security and access control, smart lighting and HVAC, and voice assistants, but also additional applications such as IoT-enabled logistics and supply chain management. The benefits of these applications and many more are driving adoption and in turn increasing the complexity of the home and small business network and creating vulnerability for users and applications. To drive this point home, the number of IoT devices connected to the internet is approximately 7 billion today. Just under 1 per person globally. By 2025, the number is expected to more than triple, equating to roughly 3 per person or nearly 22 billion active IoT devices. The gray portion of each bar represents non-IoT, general purpose devices, such as smartphones, laptops, and tablets. The number of non-IoT devices is expected to rise only modestly in comparison to IoT devices. But This growth comes with risk. The security challenges are well documented. Vulnerable IoT devices provide the fuel for botnets and other distributed threats. These may take the form of launching distributed denial of service or DDoS attacks, spreading ransomware, sending spam, and more generally enabling the theft of personal or sensitive information and creating the risk of physical harm, as many connected devices now provide a bridge between the cyber and physical worlds. The potential injuries are no longer limited to informational and privacy harms, but also now include possible physical injury and property damage. Given the sheer growth in connected devices, IoT vulnerabilities create a multitude of risks for consumers and small businesses, and the internet more broadly. The entire internet ecosystem has a responsibility to address these risks. In response, industry and government are actively trying to drive increased device security. From industry, we see a multitude of approaches, from the Open Connectivity Foundation developing a secure interoperability specification and an open source reference implementation, to CTIA conducting security testing of devices. Just last week, Etsy released its IoT security baseline. Given the risk to consumers and society, governments are also engaging to drive increased device security. Driving improved IoT security is critical, but not enough. We must address insecure devices along two paths. In addition to improving device security, we must also develop network technologies to help mitigate the risks of insecure IoT. There will always be legacy devices that don't meet current best practices and potentially manufacturers that don't follow best practices. As we saw in 2016, only a small fraction of connected devices, when compromised and used in a coordinated fashion, can significantly disrupt the operation of the internet. We must continue to drive prevention through improved device security, and at the same time, we must develop and deploy network technologies that help mitigate the risks associated with insecure IoT. To that end, I'd like to introduce CableLabs Micronets, one such approach to help mitigate the risks of insecure IoT. Micronets is a framework and a vision to bring network segmentation and other enterprise-level security controls to home and small business networks in a transparent and easy-to-use manner. In short, Micronets will enable real-time detection and quarantining of compromised IoT devices, minimizing the risk to other devices on the local network and to the broader internet. Micronets can also provide enhanced security for high-value or sensitive devices, further reducing the risk of compromise for these devices and applications. With that brief introduction, I now turn it over to my colleague Darshak to provide a more detailed discussion of Micronets.
Thank you, Mark, for defining the problem and sort of setting the stage for me. Hello, everyone. So I'm actually going to jump right into explaining what is Micronets and how it all works. So let's start with the grand vision. The idea here is to redesign and build the on-premise networks of the future. I like to call it the on-premise network as opposed to calling it home networks as we typically refer to it today, because actually, as Mark pointed out earlier, these days, these same technologies are being used extensively in small and medium businesses, and the same issues apply to them as well. So as we kind of adopt or kind of acknowledge the fact that this is going to be the status quo in the future, we need to build the technology to include or incorporate what can be done for these small and medium businesses as well as home networks. So what do we want out of this new design? First and foremost, ease of use, mainly for the consumer. If we design a solution that requires the consumer to deal with the technical stuff like installing the certificate or forwarding a port or something, we have failed. We want to provide them a seamless experience with their devices and services while improving the overall security of the network for us, for all of us. In order for us to do that, we need to automate the service management in these networks. I use the term service management instead of device management because at the end of the day, it's usually the services that these devices provide that the consumer is most interested in consuming, and that's what they're looking for. In order to provide this seamless experience, we need integrated security controls so that when things go wrong, which they will, the platform can dynamically react and take mitigating actions to protect the overall user's experience and that it doesn't get completely compromised. So with that overall vision, let's dive into the kind of the set of capabilities that are provided by the Micronets platform. The most important one is transforming this homogeneous flat network into distinct subnetworks or micronets. That's really the origin of the term. Each of these micronets represents a distinct trust domain that is managed using software-defined networking technologies. So you now have the capability to dynamically apply flow rules or flow capabilities that can be driven by specific policies. These policies in turn can be applied based on various criteria, like it could be based on the actual identity of the device or the capability of the device, or it could even be based on specific activities that are happening in and out of the network. So with that, to understand kind of how these policy things actually work, let's look at how the architecture actually looks like and how it works. So this is a kind of a visual of the Micronet segmentation and how the trust domains would look like. In the very center, let me walk through this. So in the very center, you have the black box. That's the Micronet's enabled gateway. So this could be an operator provided box with an integrated cable modem and a wireless access point, or it could even be a standalone device that the consumer acquires or gets. The gateway is responsible for enforcing the micronets, and it uses software-defined networking to control the traffic routing from all of these micronets. And you can see all of these colored lines in there that kind of represents each separate micronet. These controls, so the controls that are sent to the gateway, or kind of the policies sent to the gateway, are being managed by a set of microservices that are actually responsible for the creation and management of these micronets. And you can see kind of these micronets services in the top left corner. So that's where I think, and I'll talk a little bit more about that later on. You can also see some micronets that are already created in there, right? So if you look on the left side, you have that home automation micronet with some home automation devices. On the right side, you can see kind of a health micronet or healthcare micronet, which may have a blood glucose monitor or a blood pressure monitor that's kind of connected to that micronet. You can even have a micronet for your smart car to allow secure updates and diagnostics for your car, or even for your entertainment devices so that you can share that with your friend. Now, let's say somebody found a vulnerability in one of your devices, right, and compromised it. Let's say it's one of that webcam in the home security micronet that's at the bottom kind of left side. Now, as soon as the system detects some abnormal behavior, it can actually proactively go ahead and create a new micronet, quarantine that particular device into that separate micronet, and send a notification to the user that something is going wrong with that particular webcam. The micronets allows you to still let the webcam maybe connect to some specific services, or even let the user connect to the webcam so that they can still use it or look at it. But it at the same time make sure that the webcam is kind of prevented from talking to all of the other devices that are in those different micronets, so that it doesn't spread whatever malware or whatever infection that the device already has. So that's kind of just one example of the controls that are provided by the Micronets platform. These same controls can actually even be used to enable other advanced services. And to understand that, let's take an example of the healthcare devices that I talked about earlier. So you can see the healthcare micronet on the right side with the blue line. So maybe let's say that contains a blood glucose monitor that needs to continually report the readings back to the doctor's office. Now, one thing I wanted to mention here before I go into the details is, when I talk about micronets, I'm not just talking about doing segmentation based on VLANs, or as is commonly seen, like doing multiple SSIDs. So you just create different SSIDs for different devices. You can do that, but that's not really the secret sauce, so to speak, of the Micronets platform. Each of the micronet is essentially a distinct IP subnet, and the platform allows you to manage the connectivity within and between these micronets, and to even endpoints that are outside of these micronets. So going back to the healthcare or the health micronet, so we now have the capability to provide advanced services like secure medical connectivity to the health micronet just from the doctor's office, so that the devices there can only talk to specific endpoints in the doctor's office, or maybe the electronic health records or the manufacturer's website, but nothing else, because they probably don't need to talk to anything else. So these Okay, this opens up a whole set of capabilities beyond just security that you can deliver or enable with the help of micronets. Let me jump now kind of to the 10,000 feet, somewhat technical view of the architecture. So this is more of a component diagram of the same architecture, the same thing that we saw on the slide earlier. So right there at the bottom, you again see the Micronet's enabled gateway. That is the thing that is actually on premise, right, that you deploy. That would be responsible for enforcing and managing all the micronets. This gateway again is connected or is in communication with a set of what we're calling as the micronets microservice layer that are running in the cloud. Now, I do want to call out here that when I say cloud, I kind of mean it in a very loose sense of it. These days, there are a lot of cloud components that are actually being pushed towards the edge, especially with a lot of this virtualization capabilities. So the key point here is that these are logical microservices that can be deployed differently based on an operator's overall architecture. These microservices, in turn, exposes APIs that can communicate with different kinds of business and intelligence services, which is where kind of these different policies can come from. A prime example of this thing would be like an AI or machine learning based device fingerprinting service. These days, we are seeing a lot of these techniques and tools being offered by a lot of solution providers. So the platform can then facilitate getting the relevant data out from the network and deliver it to these kinds of services so that they can do that analytics and whatever secret sauce or machine learning that they do. And then they can provide rules and policies that are applied dynamically to the network using software-defined networking. That kind of goes towards the example that we saw on the earlier slide about quarantining the webcam based on some malicious behavior or traffic. On the right side here in this slide, you can also see a set of APIs that are exposed by the platform to integrate different kinds of advanced services. Earlier, I mentioned the healthcare service and kind of walked you through that a little bit. So these APIs that are shown on the right side, those will be the ones that would be used by this kind of service providers or different providers for the creation and management of these services and the micronets that we talked about. And in fact, we actually even have a demo that we have implemented with actual code that specifically implements this use case. So speaking of demos and code, let me talk about our implementation and kind of the reference implementation. So we have made available as proof of concept the code that implements the whole reference architecture that we saw on the slide earlier. And there are quite a few pieces or components that are available as part of this code base. So there's a link that's provided on the slide. You can go to that link to actually get information about where all of those the code components are. The code itself is hosted on GitHub, but you can actually get access to those those things from this link that's provided. And let me just quickly walk through all the different components that we have so that depending upon who you are or what you might be interested in, you can go and look at specific pieces. So the first, one of the most important, I guess, component is the software that actually goes on the gateway itself. So this is the SDN switch and the integration of this SDN switch with the wireless access point software to enable this dynamic microsegmentation. So if you are a gateway device maker or integrator, that would be the component you would be most interested in. Then we also have a proof of concept implementation of the various microservices that an operator would typically deploy and integrate within their own infrastructure. And there's sort of a reference APIs that we have implemented to demonstrate how that would look like. The third component is some prototype code that we have developed to demonstrate how the specific IoT devices, right? After all, we are building all of these to be able to manage these IoT devices. So we have some kind of prototype IoT devices that we have implemented that also demonstrates or leverages some of the new, I guess, features that are being developed in existing specifications and technical standards. And I'll talk about that in a minute later on. But so if you are kind of an IoT device maker or are building something to integrate this, that would be something that might be of interest to you. One other thing I wanted to mention is earlier I talked about leveraging this kind of the business and intelligence services like AI and machine learning based IoT security. And to that end, we are actually in discussions with a number of companies who are building these solutions to define a set of common APIs that are standardized. And this standardized APIs would allow them to access whatever information they typically need to access from this, from the gateway or from the networks to be able to do their intelligence gathering or intelligent analytics. So currently, the common deployment model is these kinds of services would need to deploy some sort of a dedicated software on the gateway itself, which actually has a lot of costly integration and scalability issues, both for the provider of the solutions, because now they have to target different platforms, as well as for the service provider, because now they have to make sure if they want to change or if they want to update the software, they have to do it on all of these multiple devices. So if you are interested in that, please you definitely reach out to me and I can talk to you about how to engage in this collaboration or this working group. Speaking of standards, I mentioned earlier about device onboarding and some standard work. I don't want to go into too much detail, but I'll briefly mention kind of two main things that are already being integrated into the Micronet's platform. One is there's a Wi-Fi standard that was announced last year called Easy Connect, which allows you to easily onboard kind of this IoT or new devices onto your network in a way that it is actually secure, and you can provide better security and better credentials to these devices. So we are leveraging that capability and actually have integrated that into the Micronet's platform. The other one is there's work going on in IETF around what is called as IET MUD. It's MUD, which stands for Manufacturer Usage Description. So MUD is a way for device makers or the device vendors to provide what is called as a MUD file, and it helps them provide the set of capabilities or functionality that the device would need in order to function correctly, on the network. So this could be in the form of specifying what protocols the device uses or what kind of ports it needs to have open. And that information in turn can help us again drive back into that policy-based SDN or the rules that I talked about. So we are actually also leveraging that into the Micronet's platform. So in short, Micronets encompasses a number of these techniques to build this platform that can evolve over time. And that's kind of our main goal. So with that, I'm going to start wrapping up my segment, which means I want us all to get into action. As I mentioned in the earlier slide, depending upon who you are, right, or what you are interested in, whether you are a gateway vendor or a service provider, that is an opportunity for you to be a part of the development process. And this will actually help you incorporate these advanced capabilities in your products. So I would definitely encourage you all to go to the links that are provided, come talk to us. And if you are interested in, as I mentioned earlier, the AI machine learning collaborators group, please definitely contact me and I can provide you information about getting engaged. If you just wish to be in the loop on Micronets and kind of follow the evolution, you can also sign up for updates at the link provided in the slide here. And you can always contact me for any questions or any information that you would like to have. My email address is right here. And with that, let's see if there are any questions from the audience that we want to address at this point of time.
Okay, thanks, Darshak and Mark. You guys covered a lot of valuable information there, and indeed there are several audience questions that have come in. And if you joined us late, members of the audience, how you ask your question, you type it in with the software toolbar, and we'll field what you submit as we're about to do right now. So let's jump in here. Darshak, first question. Will Micronets require new CPE, or is this something that can be implemented solely with new software?
That's actually a good question. So I'll give a little bit of a complex answer, I guess, depending upon what your CPE is. So if you have been deploying CPE, one of the recent CPEs that you are deploying, right, in the past year or two, a couple of years, that actually has, for the most part, the capabilities and the hardware to implement the Micronets platform or the stack. If you, of course, have older CPEs, they may need to be upgraded in order to kind of get the full benefit of these micronets. There are still a whole set of features in micronets that you can leverage, and there are some that can definitely be leveraged or deployed in existing CPE in the form of a software upgrade.
Okay, thanks, Darshak. Next question, a little bit different here. What is the connection between micronets and network slicing in 5G?
That's an interesting question. I'm just thinking, Mark, do you want to take that one or?
Thanks, Glenn. I think there is some analogy between the two, but there are definitely differences in the underlying technology and implementation. I think that comparison is beyond the scope of today's presentation, but we'd happy to follow up afterwards.
Okay, fair enough. Darshak, a number of technical questions coming in here, a lot around the Micronets gateway.
Mhm.
What sort of hardware is the gateway? Is it a standalone unit, something you see embedded in a MSO CPE like a cable modem? Could you elaborate?
I guess the answer is all of the above, right? So you can certainly implement it on as a standalone gateway. And in fact, our current reference implementation that we have is on kind of two different platforms. One is we're just putting it on a kind of a gateway like Linux box, right, just for initial development. And then the other target platform that we are using for testing is like a OpenWRT based router that you can just buy from Amazon and install it on that. Now that same code you can of course go and integrate, and we have actually been in discussions with some of our members about deploying that into your MSO or service provided gateways also, right?
Mhm.
And so I guess for the most part, whatever gateways current generation gateways you are using would be a good target.
Okay, thanks. Another question for you, Darshak. How much support is needed in the CMTS to enable micronets?
That's a good question. So for the most part, micronets works at a layer sort of above, in some sense, above the IP layer, because on one side, it's actually managing or redesigning the on-premise network. So to deploy almost most of the capabilities, you don't really need anything new to be done in the CMTS. You can keep your existing, HFC architecture, and the micronets can run completely over it.
Okay, let's let you rest a little bit here, and we'll get Mark into the action here. So Mark, the cable industry recently announced a new technology platform called 10G with the goal of delivering speeds 10 times faster than today's broadband. How does micronets fit in?
So thanks, Glenn. So the 10G platform is about higher speeds, higher capacity, 10 gigabit service. It's about low latency, sub 1 microsecond latency, and it's about security. And this is where micronets fits in. Micronets is one of the technologies that fits under the 10G umbrella and helps drive that increased security for the networks of the future.
And Darshak, let's get you back here. Let's just do one more question. We'll move on to our final speaker, and then we'll field the remainder of the questions during the last segment here. So let's see. Will the Micronets manager continue to protect the on-premise network when the internet connection is down?
Yes, that's actually a great question. So that, and in fact, that's one of the things we are working on in our POC to provide this kind of high availability and resiliency. The way it would work is you may not be able to provide new or deliver new advanced capabilities because of course your internet is down, but whatever you have, whatever policies that are already pushed or deployed, right, will continue to operate. Of course, we have to make them operate. Right? We cannot have devices just not work. So yes, the short answer is yes.
Okay, thanks, Mark. Thanks, Darshak. Audience, we're going to pause right here. Great set of questions. We've got many more that we'll field during the break after our final speaker. And allow me to introduce our final speaker, and that's Matt Tooley, Vice President of Broadband Technology at the NCTA. Matt?
Great. Thanks, Glenn. Thanks, Darshak. Thanks, Mark. So I want to take a few minutes here to explain how Micronets fits into the cybersecurity policy landscape and how it addresses one of the growing areas of concern, IoT security. Cybersecurity and securing our networks from attacks is a hot topic with policymakers here in Washington, D.C., and I'm going to explain how the Micronets framework can help operators better manage their networks from malicious IoT activity. So back on October 26th of 2016, the largest reported distributed denial of service attack, or DDoS attack, was reported. This attack caused major disruptions to large parts of the internet in the US and in Europe. And later, the root cause of the attack was attributed to the Mirai botnet. The Mirai botnet infected vulnerable IoT devices such as network-attached cameras, and then used the firepower of hundreds of thousands of these vulnerable cameras to orchestrate a DDoS attack against the internet. This large-scale DDoS attack is just one example of a cybersecurity attack that has prompted the US government to action to improve our nation's cybersecurity posture. The Mirai botnet also brought to light a new attack surface and vector, the Internet of Things. On May 11th, 2017, the President signed Executive Order 13800, or better known as Strengthening the Cybersecurity of Federal Networks and Critical Infrastructure. This executive order instructed the Department of Commerce and the Department of Homeland Security to identify and promote action to reduce the threats from botnets. A year-long process concluded with the Department of Commerce and the Department of Homeland Security publishing a report in May of 2018 with 5 complementary goals and more than 20 suggested actions for key stakeholders to take to achieve these goals. And later in the year, a roadmap was published that further prioritized the actions and identified over 85 tasks that needed to be done to achieve these goals. The roadmap lays out tasks related to each action in the context of 5 lines of effort: the Internet of Things, enterprise, internet infrastructure, technology development and transition, and awareness and education. So, where does Micronets fit into all of this? Micronets helps to address multiple lines of effort in the botnet roadmap. In particular, the IoT and enterprise lines of effort. In the IoT effort, the roadmap includes a work stream developing robust markets for trustworthy IoT devices. This effort will develop a core set of security capabilities. The actions here are focused on improving future IoT devices, but does nothing for legacy IoT devices. And this is one place where Micronets helps, as it provides a framework for network management that works with all legacy devices installed, such as the web cameras used by Mirai. Also in the IoT effort, the roadmap calls for adoption and sustainability for IoT security, which is a portfolio of actions to enhance the security of IoT products and promote confidence in the IoT marketplace that includes extending risk management for IoT. And again, Micronets helps here as it provides a framework that can be used as part of an IoT risk management program. And then finally, the other work stream that Micronet helps with is with the enterprise line of effort, in particular, advanced network architectures work stream. The botnet report recommends that enterprises should migrate to network architectures that facilitate disruption and mitigation of automated distributed threats such as botnets. The Micronet framework provides a great foundation for extending the enterprise network management all the way to the edge of the network, including consumer networks, to mitigate against the malicious activity from IoT devices. And again, with the Mirai example, the use of Micronets would have allowed for quick identification and then the quarantining of the vulnerable devices. As discussed here today, we see Micronets as a great platform for managing devices on the home and business networks. IoT security is just one use case for Micronets, but is not limited to IoT security. Micronets is a platform for managing the growing number of devices on home and business networks. I would encourage developers, equipment manufacturers, managed service providers, and ISPs to reach out to Darshak and the Cable Labs team to learn more about how to include support for Micronets in your next project or product. Thank you.
Okay, great. Thanks, Matt. And jumping right in here, you showed a couple of slides with executive orders and things that have occurred over the last couple of years. How do you see the year ahead or next 18 months in terms of cybersecurity policy?
There are a lot of activities mapped out there, so I see a lot of activity getting done by stakeholders across the whole ecosystem as we all work as a community to improve the overall cybersecurity posture. The NTIA team is looking to have a status report that they will be providing back to the president in about a year that will give him an update on, how we're all doing on achieving this.
Great, thanks. And what about internationally? I know you're mostly focused on domestic United States based, but I know we have a lot of people on the webinar today from outside the US. Anything that you want to comment on there?
No, it's a good question. One of the challenges we face is the need for some common cybersecurity policies at a global level. Lots of countries are, seeing a need to come up with policies. So different countries are at different points at trying to advance a cybersecurity policy. Not everybody's aligned and in the same place. So, we see, the United States in some of this is trying to lead the effort and drive it in a common direction. And we think Micronets is a great addition to helping move this forward.
Well, let's open the Q&A to all three speakers here. And Darshak, just looking at what's come in, you're going to get the brunt of the load here because there's a lot of really good technical questions. So keep your answers short, and we'll try and get through as many of these as we can. So a question is, how does it actually work? How is the traffic isolation on the home network? How is that occurring?
Okay, so without going into too much detail, right? So if you think about SDN, right, it's mainly about being able to separate what is called as your control plane from your data plane, right? So the data plane is actually your traffic that's going over the home network. And that's really what we are leveraging with Micronets. So on the home gateway is where you actually have even right now, you have your router or your SDN switch, as it is called in the SDN world, is the one that actually has these rules and policies that can be dynamically changed by controls that you have outside. So that's really the crux of it, is you have an SDN switch that is dynamically, manipulating the traffic, right, and making sure that only traffic that is allowed is allowed through a specific Micronet. And again, without going into too much details, the main difference is, if you think about today's routers, right, you actually kind of set up your router, and if you want to make any changes into your router, you literally have to go into your router interface, which might be different for everybody else. And once you set a policy, it's kind of static unless you go again and change that policy manually. That's the one thing that Micronets changes, because now your routing rules or all of your forwarding rules can be dynamically changed based on things that are happening, and that there's something intelligent in the cloud that's taking those decisions and pushing that information. So I would be happy to talk in more detail about it, but yeah.
Yep, good answer there. And we're going to keep rolling here. What about overhead? Is there overhead being added through a Micronets equipped gateway? Could you talk about that?
There is definitely some, I guess, overhead in terms of I wouldn't say overhead, but it's more about some hardware capabilities, right? So you do need as I mentioned, right, a current generation hardware gateway, but for the most part, they already have the capabilities to be able to implement that. And of course, it's also going to be a matter of working with the device vendors to actually improve the performance and efficiency of this software, right, on that specific platform. The other flip side of it is we are also removing a lot of management layer stuff that typically is in routers these days. So you are actually removing some of the overhead that's there and moving it somewhere else, and that kind of helps you improve the performance or make your your gateway a little bit leaner in some sense.
Let's talk about the code a little bit. Will the reference implementation run on any OpenFlow switch?
Just that, in fact, it is right now running on OVS, Open vSwitch, which is the most common OpenFlow based switch, is the one that is already being used in the reference implementation. It can, as long as it talks OpenFlow, yes, it can work on any OpenFlow switch.
Let's get you back in here, Matt. I think this one, or Mark, I think this one might be good for you. Is CableLabs engaged with the Cybersecurity Act in Europe?
So thanks, Glenn. We're definitely following the recently enacted Cybersecurity Act in the European Union. With that act, ENISA, the European Agency for effectively cybersecurity, will have increased authority to potentially do cybersecurity certification of IoT devices. So we see that more on the sort of device security side of the house, and our work at the Open Connectivity Foundation, we're definitely monitoring that, and we see that work that industry is doing in OCF to potentially help with those efforts in Europe.
Okay, thanks, Mark. Let's back to you, Darshak. So follow-up questions sort of on the how it works side. Is this port-based security? Would you describe it as that? And secondly, can you isolate traffic on Wi-Fi?
Yeah, yeah. Well, so the first, no and yes. Let me put it that way. So no, it's not just port-based security, right? This is actually what I would call as capable security that allows you to isolate based on specific type of traffic from specific devices. And yes, you can isolate it over Wi-Fi. In fact, that's a very important thing that we had to work through quite a bit to make sure that we can do that correctly. So I think I even mentioned that in the slide that this is not just about creating separate SSIDs. This is also this because that doesn't really scale well. So Micronets allows you to actually create this kind of separate micro networks within on the same SSID and be able to isolate the traffic.
And audience, again, these are great questions that are coming in. Darshak, again to you, is it fair to say that the performance of the whole framework relies on the analysis in the cloud? Could you talk a little bit more about the analysis?
That's actually a very good question. I wouldn't say it completely relies on the cloud. Yes, it does rely on some of the components being in the cloud, or some of the controls being in the cloud, because that is what helps you do the dynamic part of the controls. But once you actually have done some of the analytics, you can always push some components of it or designed or predefined rules onto the gateway itself. And that kind of even goes back to the question asked earlier about if the cloud or if the connectivity goes down, what do you do, right? So depending upon the hardware capability of your gateway, you might actually even be able to deploy some components on the gateway itself using virtualization or something like that to make sure that those components can run directly on the gateway itself. Or you can move them in the cloud. So yes, it does rely on the cloud, but there are a lot of things that we can do to kind of help scale that well.
Okay, I like this next question here. Could you walk us through an example of how Micronets would have detected and quarantined a camera that was taken over by Mirai?
Okay, yeah, that's a good question, right? So when you think about the Mirai botnet, think about it this way: it took over about 100,000 webcams, right? Now, if you had a system, which nowadays a lot of systems are in there, where once you start detecting a particular signature or malware that is starting, if you detect it at one place, you now have the capability to go and dynamically push the rules to a whole bunch of other gateways that are under your control that you are managing. So in case of taking the example of Mirai, maybe let's say the first 1,000 webcams got, or devices got hacked. And from that you detected, okay, there's something fishy going on. That would allow you to take determine that signature and push rules dynamically so that if you detect that there is the same types of cameras or same type of behavior is being seen in all the other places, that's when you can start mitigating that. So you would actually be able to significantly blunt the effect of that particular malware. So again, Micronets is not, there's no guarantee in Micronets that the device is never going to get hacked or compromised.
Understood. Yep. Interesting question here. How does an end user, for example, one using a healthcare device, define a new Micronet? Is that an end user capability, or is that only service provider, a mix of both?
That's a good question. So it is a capability that an end user can use if they want to, but the whole kind of core idea behind Micronets is ease of use for the end user, right? So we don't want to depend upon the end user to be able to define the Micronets. In fact, for the most part, they shouldn't even be required to understand, different Micronets or subnets or anything else. It should just work for them. And that's where all these ideas about the features that we are talking about using IETF MUD, the capability to do onboarding using Easy Connect, all of that helps in making the end user easily connect their devices, while at the same time allows us to securely identify what each device is. You may actually, when the device is onboarding, right, ask the user to say, hey, is this your webcam, or is this your device that you're going to put in your bedroom, or is this your kid's device? So that much a user can answer. We don't want the user to go and create subnets or things like that. That's something that we do based on this information that the user provides and based on how the device gets onboarded.
Okay, let's have this be the last question here. Can you talk about device identification? Do you use MAC addresses, certificates? How does that occur?
I would say all of it. And that again goes down to the same fact that we have to build an evolvable framework. There are going to be legacy devices where you may not have anything else but a MAC address, but we know easily that the MAC address can be easily spoofed. So there's only a certain level of trust that you can establish for the device. And that's why you would put maybe those devices into a separate micronet. For devices that actually uses, let's say devices that are OCF compliant or devices that allows you to provision with either a certificate or the Wi-Fi protocols that I'm talking about, or maybe if it's a operator provided device, those devices will have a different level of trust, and those devices you can accordingly assign in a different micronet with different policies. So it allows kind of you to build this spectrum of trust, right? Which is exactly what we are going to need given the variance of devices that we are going to deal with in the future.
All right. Great job, Darshak, fielding so many questions there. Great job, Matt and Mark as well, too, for your work on the Q&A segment. Audience, really great that you're able to engage with us by typing in so many wonderful questions. Thank you to our speakers today. Mark, Matt, and Darshak did an excellent job presenting the Micronets framework and its implications and benefits. Want to thank them for their time today. And audience, we do value your feedback on the webinar, and we are going to be sending out to you a question in the next day or so. It's just a one-question survey, and ask if you could take the time to fill that out. And we do like to hear from you. We use the input that we get from you to improve our webinar products going forward. So anything is fair game. If you liked what you heard, let us know. If you think you have some suggestions for improvement or what we should cover on the next webinar, I'm happy to take your input. A couple of upcoming events on the Cable Labs calendar. We've got conferences in Europe and in Keystone this summer. As always, you should visit our website, cablelabs.com events, for an updated look at the calendar and what's coming and what you may be interested in attending. And just a plug that we do have a great blog that is updated a couple of times a week that covers a lot of topics like micronets and other emerging technologies coming out of the labs. So follow us on Twitter, come see the blog, lots of ways to stay informed. Thanks everybody for joining us today, and we will see you on the next webinar.